In this video, we'll discuss the geometric interpretation of the dot product. The dot product of two vectors can be positive, 0, or negative. A geometric interpretation of the dot product explains when each of these cases occur. This interpretation involves the angle between the two vectors. Consider vectors u equal to AB and vector v equal to CD. The angle theta between u and v is defined to be the angle having the two vectors as its sides for which theta falls in between 0 and 180 degrees. Our geometric interpretation of the dot product is defined as follows. If theta is the angle between the two non-zero vectors u and v, where theta falls between 0 and 180 degrees, then u dot v is equal to the magnitude of u times the magnitude of v times cosine of theta. Frequently, we're using this formula to find theta, so we often remember the formula instead as cosine of theta equals u dot v divided by the magnitude of u times the magnitude of v. So you'll see we just took that original equation and divided both sides by the magnitude of u times the magnitude of v. I really only remember the formula in this form because 99% of the time I'm trying to find theta, so why not have it ready to go where I just need to plug it in and then do inverse cosine. So let's find the angle between each pair of vectors. We'll round our answer to the nearest hundredth. So these vectors aren't labeled for me, so I'm going to go ahead and label them just so it keeps me straight as I'm plugging everything in. So for our formula, we need three things. We need the dot product between u and v, we need the magnitude of u, and we need the magnitude of v. So let's do each of these three things, and then we'll plug it into our formula. I'm going to start with the dot product, u dot v. That's going to be 1 times 1 plus 7 times 1. 1 plus 7, we get our dot product to be equal to 8. Great. Now we need to find the magnitude of each of our vectors. Remember, the magnitude of a vector is the square root of a squared plus b squared. So the magnitude of u is going to be equal to the square root of 1 squared plus 7 squared. That's the square root of 1 plus 49. We get the square root of 50. And we know that we can simplify that radical into 5 square root of 2. It may or may not be a benefit to actually simplify that radical. We're just going to be plugging it into the formula and then ultimately into our calculator. So personally, I probably would just leave it the square root of 50 in this context. The last thing we need is the magnitude of our vector v. So that'll be the square root of 1 squared plus 1 squared. So we get the square root of 2. We have the three pieces that we need, and we're ready to plug it into our formula. Cosine of theta is equal to u dot v divided by the magnitude of u times the magnitude of v. So up top we'll have 8. And on the bottom, we'll have the square root of 50 times the square root of 2. And you'll notice, yeah, I could plug it in my calculator now and do theta equals cosine inverse of this fraction. But personally, I'd just take a second to clean up this fraction just so it was easier for me to plug into my calculator. Square root of 50 times the square root of 2 is the square root of 100, which is 10. So I would simplify this down to cosine of theta equals 8 over 10. Yeah, I know that simplifies to 4/5, but I probably wouldn't waste my time doing that. Theta equals cosine inverse of 8 over 10. Make sure that your calculator is in degree mode, and we'll round to the nearest hundredth. We get theta to be equal to 36.87 degrees. Let's try another one. You'll notice in our next example, they gave us our vectors in our AI plus BJ form. So the first thing I would do is put it in angle brackets and label my vectors. We have U is equal to -512 and V equal to 3, 2. And just like in the previous example, we need to find three things first. We need to find the dot product between the two vectors, the magnitude of each vector, and then we'll plug it into our formula. Starting with the dot product between the two vectors, that's going to be -5 times 3 plus 12 times 2, -15 plus 24. U dot V is equal to 9. So that's the first thing we'll need. Moving on to the magnitude of U. This is going to be equal to the square root of -5 squared plus 12 squared. So that's the square root of 25 plus 144. That's the square root of 169, which is a perfect for us. The magnitude of vector U is equal to 13. And then lastly, we'll find the magnitude of our vector V. It's going to be the square root, where's my vector? There we go, of 3 squared plus 2 squared. That'll be the square root of 9 plus 4. The magnitude of vector V is the square root of 13. We have the three pieces we need. Now we're ready to put them together using our formula. Cosine of theta is equal to U dot V divided by the magnitude of U times the magnitude of V. Cosine of theta is equal to 9 divided by 13 square root of 3. There's no easy way to really simplify that quick or make it better to put in our calculator, so we're ready to go. Theta is going to be equal to cosine inverse of 9 over 13 square root of 3. Now make sure when you put this in your calculator, you got to have this 13 square root of 3 in parentheses. I'm sorry, that's 13. Square root of 13. All right, theta is going to be cosine inverse of 9 over 13 square root of 13. Rounding to the nearest hundredth, we get theta to be equal to 78.93 degrees. All right, so next we're going to learn a new vocab word. Two vectors are parallel. That's not the new vocab word. Two vectors are parallel when the angle theta between the vector is exactly 0 degrees or exactly 180 degrees. If theta is equal to 0 degrees, then the vectors point in the same direction, but if theta is equal to 180 degrees, then the vectors point in opposite directions. So they're parallel. If theta is 0, it's going in the same direction. If it's 180, it's parallel but pointing in the opposite direction. If the dot product, U dot V, equals 0 for two non-zero vectors U and V, then that means that cosine of theta would have to be equal to 0. And we know that theta equal to cosine inverse of 0, that would force theta to be 90 degrees. Thus, vectors U and V are perpendicular or orthogonal vectors. And that's our new vocab word, right? Orthogonal. It's just another way to say perpendicular, but we really only use that word in the context of vectors. So let's determine whether the vectors v equal to 2i plus 3j and vector w equal to 6i minus 4j are orthogonal or not. And the only way to do this is to find the dot product and then look at it. If the dot product equals 0, great, they're orthogonal. If it's anything other than 0, then they're not orthogonal. They gave me my vectors in AI plus BJ form, so the first thing I'm doing is I'm rewriting them with angle brackets. V equals 2, 3, and W equals 6, negative 4. And we're ready to dot them. V dot W is going to be equal to 2 times 6 plus 3 times negative 4. That's going to be 12 minus 12. We get our dot product to be 0. Therefore, we can conclude that vectors v and w are orthogonal.